Dark clouds hung over Cape Kennedy. The Saturn V stood on the launch pad carrying Apollo 12, a mission bound for the moon. Weather officers were uneasy. The sky already looked wrong. Thick cloud layers stretched across the coast, and rain drifted through the distance. Yet the countdown continued. The engines ignited. A column of fire spread beneath the rocket. Slowly, the vehicle lifted away from Earth and disappeared into the gray. At first, it looked like a dramatic but ordinary launch. Then the sky answered. 36 seconds after liftoff, lightning flashed around the ascending rocket. Not beside it. Not near it. Around it. For an instant, bright branches of electricity wrapped across the vehicle as it climbed through the clouds. The flash vanished almost as quickly as it appeared. The rocket kept flying. A few seconds later, it happened again. Another strike. Another burst of light against the storm. And then something far stranger than lightning began unfolding. Inside the spacecraft, instruments suddenly stopped making sense. Warning lights appeared. Electrical readings shifted. Values jumped where they should not jump. In mission control, telemetry screens filled with abnormal data. Measurements that had looked stable seconds earlier now seemed disconnected from reality. The temporary explanation felt obvious. Lightning had damaged the spacecraft. After all, what else could explain such a sudden collapse in information? Apollo 12 was headed toward the moon, and the spacecraft appeared to be failing. Except the rocket refused to cooperate with that explanation. The Saturn V continued climbing. Its engines kept burning. Guidance remained stable. The trajectory stayed where it was supposed to be. The vehicle looked healthy. The information describing the vehicle looked unhealthy. Those two realities should have matched. They did not. As the rocket pushed higher above the Atlantic, the contradiction became impossible to ignore. If lightning had crippled the spacecraft, why was the mission still succeeding?
I see it.
Mission control faced a problem that was becoming more uncomfortable by the second. They could see the rocket continuing its ascent. They could see data arriving from the spacecraft. But they no longer knew whether the data deserved to be trusted. The visible machine and the invisible picture of the machine were telling different stories. And Apollo 12 could not pause while people figured it out. The mission was still moving forward. Fuel was still being consumed. Milestones were still approaching. Every minute carried the spacecraft closer to decisions that could not easily be reversed. The moon was waiting. Certainty was not. The strange readings continued. Electrical systems reported conditions that did not fit the behavior of the vehicle.
It's still anomalous.
Some indications suggested serious trouble. Others suggested normal operation. The picture shifted from failure to confusion. Nobody could confidently separate actual damage from corrupted information. Then a recommendation emerged. One controller remembered a rarely used procedure involving a switch inside the command module. The switch carried an unfamiliar label, SCE to AUX. The crew moved it. A hand reached across the panel and flipped the switch. Almost immediately, telemetry began returning. Numbers stabilized. Data streams became readable. Mission control could see the spacecraft again. For a moment, the crisis appeared finished. The famous switch seemed to have solved everything. The audience could easily believe the story was over. Lightning struck. Systems failed. The correct switch restored them. Problem solved. But that ending arrived too early. Because recovered telemetry was not the same thing as recovered trust. The screens were working again. That did not automatically prove the spacecraft was
Copy that,
healthy.
GNC. Monitor the power
Visibility had returned.
Roger, flight. We are tracking.
Reality
burn.
remained uncertain. The rocket reached orbit. Against all expectations, Apollo 12 circled Earth calmly above the atmosphere.
red switch, up, down,
From a
and
distance, the spacecraft looked
Verified.
perfectly normal. The crew began systematic checks. Controllers reviewed system after system. Electrical equipment, navigation systems, communications, power supplies. Each verification mattered for the same reason. The mission was approaching a point where commitment would deepen dramatically. Continuing toward the moon would carry the spacecraft hundreds of thousands of miles away. If hidden damage remained undiscovered, options would shrink rapidly.
Listen up.
The
We're
pressure
past the
was no
anomaly
longer
review.
fixing
Let's
telemetry.
focus on the maneuver timeline.
The pressure was
Prepare for
deciding
decision.
how much confidence was enough. One by one, the checks accumulated. The spacecraft continued behaving normally. Evidence slowly began pushing against the original explanation. Lightning had clearly disrupted the mission. But the disruption appeared concentrated in how information was being reported rather than in the health of the spacecraft itself. The distinction mattered enormously. A damaged spacecraft and a damaged picture of a spacecraft could look remarkably similar at first. Only time and verification could separate them. Orbit after orbit, confidence gradually returned. Not all at once, not through a dramatic revelation, through observation, through consistency, through systems continuing to perform exactly as they should. Eventually, NASA reached the decision that mattered most. Apollo 12 would continue. The spacecraft left Earth orbit and headed for the moon. The mission succeeded. The crew completed their lunar objectives. They returned safely home. Looking back, it is tempting to treat the lightning strikes as the central event.
Com status is
They are
green.
certainly
Flight.
the image people remember.
Telemetry.
A
stable.
moon rocket climbing
systems
into
go.
a storm,
We are proceeding with the maneuver.
electricity branching across its skin. A launch that should never have looked so vulnerable. But that image hides the deeper story. The real crisis began after the flashes disappeared. The dangerous moment was not simply that lightning struck. It was that trusted information vanished while the mission continued moving forward. The rocket never exploded. The spacecraft never visibly failed. Instead, certainty slowly drained away while commitment increased. NASA later revised its understanding of electrical launch risks and tightened weather rules for future missions. Yet the lasting lesson reached beyond storms. Exploration depends on hardware. It depends on engines, fuel, computers, and spacecraft. But Apollo 12 revealed something equally important. Exploration also depends on confidence in reality itself. The Saturn V disappeared into dark clouds as a launch vehicle heading for the moon. When it emerged from the crisis, it had become something else. A reminder that the most dangerous thing a mission can lose is not power, not altitude, not even time. It is the ability to know whether what it is seeing is true.